All right, section 8.2. Going to get into linear equations in two variables. If you remember 8.1, we looked at what is a function, and now we're going to look at a specific function, which is linear equations. All right, so we want to be able to solve linear equations with two variables and also graph linear equations using ordered pairs, right? We're going to look at a lot of different methods to graph, and the first one we're going to look at is just by plotting ordered pairs. Right, our key terms, linear just means line, okay, and a linear function has a constant rate of change, which we'll find out is called the slope, and it determines how steep it is, whether it increases being positive, whether it decreases when it's negative. A linear equation in two variable is an equation in which the variables are in separate terms. Maybe you have an x term and a y term, and neither variable contains an exponent other than one, right? In order to be linear, the exponents on the x and the y have to be one. And it's not written there, but we understand that those are going to be one. So if we look at some examples, we have y equals 2x plus 4. This is slope-intercept. This is a very popular form of a linear equation where it's y equals something. This is called standard form when x and y are on the same side. And it's also linear. The exponents are still 1. They're separate x and y terms. This is a slope-intercept form, right? The y is just on the other side. It's still y equals. You have an x term and a y term. Another standard form example. And we can rewrite these, meaning I could make this standard form look like slope-intercept, right? If I add an x to both sides, right, this would be y, right? That would cancel. So equals 7 plus x, right? So we can solve it for y so it looks like that as well. And we'll look at some examples where it might be beneficial for us to do that. Now, visually, looking at what it means to be linear. Okay, linear is a straight line, right, with a constant rate of change. So kind of like a slope, right? This is, yes, that's a linear function, right? It's increasing the same all the way through the graph. This yes, that is a linear function, is a straight line decreasing at the same rate all the way across. Here, another one, yes. Okay, don't mind the little bump there. Those are supposed to be straight. I'm just not the greatest at drawing those lines, but it is increasing, right? Not as much as the first one, but it's still increasing as we go in a constant rate. Here, notice it's coming down and then goes back up. This is actually a quadratic, meaning an x squared function. That is not linear. It's not a constant rate of change. Same here. This is a no. This is actually a cubic function, right? An x to the third function. And then this last one here, this would be, yes, that's linear. There's no slope. It's just a flat line here. All right. Trying to make the connection to all of the different ways that you can represent a function, right? You can represent it as words, right? And that's a lot of times where it starts. You're modeling a situation. So we'll look at this one all the way through, right? Peaches cost $2 per can, right? Easy enough. And it might start out as a table, right? Where you say, okay, well, what if the different number of cans, right? If I have 0 cans, that's going to cost me nothing. If I have 1 can, that can is going to cost $2, right? Because it says per can. If I have 2 cans, it's going to be 4. 3 is going to be 6. 4 is going to be 8, right? 5 is going to be 10. I could keep that going, right? I can represent this table in ordered pairs, right? And that'll allow me to graph this situation, right? I can plot 0, 0. 1 can would cost $2. 2 cans would cost $4. 3 cans would cost $6. 4 cans, right? We're kind of running out of room, would cost $8, and so on, right? And even though we don't have negatives, right, you can see that this is a constant rate of change. And so if I were to graph it, right, to model this situation, it really only goes in this direction, right? But if I were to graph it, it would also continue down, pretending that's straight, in that direction there, right? A straight line. Okay. And our constant change, if we notice what's happening each time we go up one on the cans, this is going up by two, right? $2 per can, right? So we just multiply the number of cans by two. And if you look, y is the cost and x is the number of cans, right, in my equation. So if I wanted to figure out what does 10 cans cost, right? Well, it's 2 times 10, right? $2 per can. That would be $20. So the equation allows me to figure out any value of x or y. So you can see that we have words, table, ordered pairs, graphs, equations. All of those are different ways to represent that function of peaches costing $2 per can. All right, now finding solutions. All right. And there's an infinite number of solutions out there, right? We're going to look at just specifically finding 4 solutions. And you can choose any value you want for x. Typically, our answer key is going to do -1, 0, 1, and 2, right? So those would be 4. I left this one blank just to show you that we can do any number if we want to. So it says find 4 solutions, because notice we have 2 variables here and we can only solve for one at a time. If you remember back to our solving equations, the equation would have been like 10 equals 2x minus 1, and we had to solve for x, right? So if this were our case, we would say, oh, all right, well, um, instead of having a specific value here, we're just going to say y. All right. And what that allows us to do is it's going to allow us to plug in different values for x to determine what does y equal. So we're going to input these x values into the equation, and we're going to figure out what does that y equal from that, right? So I've chosen these. There's nothing special about them. They're just easy numbers to use. And I just plugged them in, right? So right here, I took my equation. Instead of writing x, I left that blank, and I'm going to fill in values for that. So here, 2 times -1 is -2, minus 1 is -3. So what that tells me is that when x is -1, y is -3. Here, when it's 0, 2 times 0 is 0, minus 1 is -1. So at 0, we have -1 for y. This would be 2 minus 1 is 1. So when x is 1, y is 1. And then here 2 times 2 is 4, minus 1 is 3. So when x is 2, y is 3. And if you notice, right, as we went up each time for x, my y value went up by 2, right? And that's because that constant rate of change was 2 in this example, right? Whatever you're multiplying by x, that's going to be your rate of change as long as it's y equals. Now, I can pick any value, right? I didn't have to pick those. So when it says find 4, I could have said, all right, well, let's find what 10 is equal to. And I just plug that in, right? 2 times 10 is 20, minus 1 is 19. So my coordinate 10, 19 is also a solution on that graph, all right? But note, most of your answer keys are going to be this, and it'll say answers vary, all right? But we'll get used to plugging in these. Now, it's not always going to be beneficial for us to do that, meaning if I wanted to avoid decimals, all right? So for example, in this case, right, 0 is always a good one to plug in. Okay, so let's plug in 0. So 1/3 times 0 is 0, plus 1 is 1. So 0, 1 is going to be a coordinate. And I could plug in 1, right? But then we're going to introduce fractions. Okay, so 1/3 times 1 is 1/3, plus 1 is 1 and 1/3. So we have 1, 1 and 1/3. So I'm going to teach you a little trick. When you have fractions there and you get the choice of what to plug in a multiple of the denominator. So I'm going to back this up just so we don't have to deal with fractions. And instead of plugging in 1 as my next number, I'm going to plug in 3, right? So 1/3 times 3 is 1, plus 1 is 2. So 3, 2 is a solution. Next multiple would be 6. So 1/3 times 6 is 2, right? Because remember, multiplying by 1/3 is the same as dividing by the 3, right? So that'd be 2 plus 1, which is 3. So we have 6, 3. And we could plug in 9, right? 1/3 times 9 is 3, plus 1 is 4. So 9, 4 is another solution, right? And let's pick one. Let's do a negative. Let's just plug in -3. Right, 1/3 times -3 is going to be -1 plus 1 is 0. So -3, 0 is also a point. Kind of a special case here. Y equals 5, right? And if you notice, if you look at that, you're like, well, that's not really two variables. Um, there's nowhere to plug in x, right? And another way to write this is 0x plus 5, right? There's no x. So essentially, no matter what, if x is -1, y is going to equal 5. Okay, it's telling me what it is, right? If x is 0, there's nowhere to plug it in. Y is going to be 5. If x is 1, y is 5. If x is 2, y is equal to 5, right? Because no matter what we plug in here, 0 times that's going to be 0. You're always going to end up with just that 5, right? So I could say 1,000, y is going to be 5, right? So no matter what, y is going to equal 5. Right, and just visually, just so you can see, you might be thinking, like, what the heck does that even mean? So x is -1. Let's say here's 5 right here. So there's the point. At 0, it's equal to 5. At 1, it's equal to 5. At 2, it's equal to 5. At 1,000, it's equal to 5. So it's just this flat line with a constant rate of change of 0, right? There's no change. There's no x change there, so it's always going to equal 5. Now, I put solve for y first because sometimes it's going to say you might want to solve for y first. And when y is by itself, meaning there's no coefficient, there's no number except for 1 right here, it's pretty easy to solve for y first. But if you look down at this next one, where you have 2x and 2y, there's that number there. It's a little more confusing. So I wouldn't say you have to solve for y first, but we'll look at it both ways. So let's first look at it without. So let's just do 0, 1, 2. Back up. I told you already what the answer keys are going to be. It's going to be -1, 0, 1, and 2. So let's just do that. So we're saying 2 times -1 plus y equals 15. Okay, so 2 times -1, right, I'm just going to write this over here, is -2 plus y equals 15. So what would I have to do to solve this for y? I'd have to add 2 to both sides. So we get y equals 17. So -1, 17 is a coordinate. So you can see that I plugged it in and then I had to solve later. Now, if I wanted to solve for y first, right, I could subtract 2x from both sides. So in doing that, it would cancel and we would have y equals 15 minus 2x. Right, so then y equals 15 minus 2 times 0. So that allows me just to plug it in. Well, what's -2 times 0? It's 0. 15 minus 0 is 15. So 0, 15 is a solution. Y equals 15 minus 2 times 1. right? 15 minus 2 times 1. So 15 minus 2 is 13, right? And we should see the pattern by now. So when it's 1, this would be 13, right? What's happening each time? It's going down by 2. So this should be 11, right? If I go one more here, this should be 9, all right? And we can double check. I can say y equals 15 minus 2 times 3, right? So 15 minus 6, does that equal 9? Yep. So you should be able to see the pattern after a few times going down the list there. So what I want you to do is I want you to try and find the y value, right? And you're probably thinking, oh, great, this is the hardest one we've tried so far. And you're right. It is, but I believe you can do it. So pause the video here, and we can even set up the first one, right? So 2 parenthesis negative 1 plus 2y equals 10. All right, that's what we're trying to solve. So pause the video and see if you can just do the first one, right? We'll check the first one and then we'll move on from there. All right, how many of you were able to get 6? All right, so negative 1. Oops. So negative 1, 6 would be a point on our graph. So if you look here, I rewrote it, right? I did 2 times negative 1, so that's negative 2 plus 2y equals 10, right? So this is back to our last chapter, solving a two-step equation. The opposite of minus 2 is plus, so I added 2 to both sides. So I got 2y equals 12, divide, and we get 6. Okay, let's go 0 now. So if I plug in 2 times 0 plus 2y equals 10. All right, so what I'm going to do is I'm going to go back up here just so I have some more space. And I'm going to write that back out. So 2 times 0 is 0, right? So that just cancels. Plus 2y equals 10, right? So, I mean, I could subtract 0 from both sides, but it's just 0, so it's really not affecting my problem. So 2 times something equals 10, right? I should divide by 2, get y equals 5. And hopefully we'll see a pattern emerge here, right? Remember, it's a constant rate of change, so as long as I'm changing by ones over here, we should see that pattern emerge. So 2 times 1 is 2 plus 2y equals 10. So I'm going to go minus 2 from both sides. We get 2y equals 8. Divide by 2. We get y equals 4, right? So hopefully we can guess, right? When we just went up by 1 there, this should be 3. So that gives me 0, 5, 1, 4, and 2, 3 as solutions of that equation, 2x plus 2y equals 10, right? And there's a bunch more, right? You could say x is 10, figure out what y would be. All right. So it says, this one just gives a word example with it. It says fancy goldfish costs $3 and regular goldfish cost $1. Find 4 solutions of the equation. Now, let's first decide why that is the equation, right? So it's saying that this is our fancy and this is our regular goldfish, right? So it's $3 per fancy plus $1, right? And I could write the 1 there, but notice that it's not. It's understood to be there. Plus $1 for the regular, and I have $8 to spend. So I want to determine how many fish I can buy for $8. So let's say, all right, I want to buy 0, right? Because you can't buy negative fish. So that'd be silly to put a -1 in there. But we'll say let's buy 0 of the fancy goldfish, right? So 3 times 0 plus y equals 8, right? Well, 3 times 0 is 0. So this would be 8, right? And that makes sense. If I spend $0 on the fancy fish, the regular fish are $1, I can get 8 of them. All right, so then let's just say we buy one of the fancy, right? 3 times 1 plus y equals 8, right? So I spent $3 on the fancy, right? Which leaves me with how much money left for the regular, right? And so if I went minus 3 from both sides, it leaves me with y equals 5, right? It's $5 left after spending 3, and then I can buy 5 of the regular fish for $1. So if I bought one fancy, I could buy 5 of the regular, right? Let's try 2 fancy, right? So 3 times 2 plus y equals 8, right? 3 times 2 would be 6. So if I subtract that from the other side, that leaves me with $2 to spend, and that means I could get 2 regular fish and 2 fancy fish. 3, right? 3 times 3 is 9, so I couldn't buy 3. So these are all my combinations of fish that I could buy for $8. All right, I'm gonna do it kind of different. We're gonna break this up into 2 days. So if you are at home, you can click on the 8-2 practice link in the agenda and try problems 1 to 6. They're going to be very similar to what these were, and saying find 4 solutions, and you can plug in whatever you want. However, your answer key will be just like what we did before. It'll find the x's -1, 0, 1, and 2. So if you want to check, right, your 4 answers, I would use those 4 as your x values in those problems. All right, so you'll work on those today. And then when we come back on Thursday, we'll get the second half of 8-2 notes, and you'll be able to finish that worksheet. So you just got the 6 problems today. And then when we get to Thursday, you'll finish it up, and there'll be an answer key for you to check your work. In-person students, your crew teachers should have a hard copy for you to use. All right, if you have any questions, let me know. I hope you all have a great day, and we'll talk to you soon.